here are my questions for you guys. First off, I guess that everyone will probably guess whenever you see like a function and its inverse, right, get together. So you think that, can we just get the 4 pi over 5, right? You know, since the sine and the sine inverse, you know, killed each other, right? But what's wrong with 4 pi over 5? That's my first question. What's wrong with it? It's too big, right? It's beyond the range of sine inverse. And you guys know the sine inverse has the range from negative pi over 2 to pi over 2, right? So that's the first thing. It's wrong to have the 4 pi over 5 back. Now, the second question is, I mean, then we're looking for an angle, right? Let's call it theta prime, that goes into the range of the sine inverse, right? But why am I drawing this graph? To assist, you know, the process of finding the theta prime. Right? What's the logic behind this graph? Well, I guess that everyone understands that why am I having sine theta prime equals to sine pi 4 pi over 5, right? But when I draw the angle 4 pi over 5, it's in the second quadrant, and I pick the point on the terminal side. I'm relating sine of this angle to the y coordinate of the point on the terminal side. You know, why is that? Can we define the sine as y for the unit circle definition, right? So now sine is y, and that's why you take the y coordinate to see better how would you relate the angle to the value you want so that you can find another angle with the same y value, right? Or if you pick a point on the new terminal side you're going to draw, make sure that the point better have the same exact y value, right? Even if sometimes you think about, oh, it's just the distance, right, in a vertical direction, the sign does matter. I cannot have any point in the lower half of the plane because those y's can be negative, right? I want a positive y. Do you see that? There's only one quadrant you can draw the terminal side. That will be the first quadrant, right? Now, how would you make another terminal side so that a point on it will have the same exact y coordinate as the one you draw, you know, for 4 pi over 5? Don't you make, you know, whatever you have drawn reflected off around the y-axis, right? So that those 2 points will be exactly symmetrical about the y, like a mirror image. And this is the y value, right? So that means I'm looking for this angle. Now, of course, you know, later on, it gets a bit confusing because I want you to see that this angle is the same as the supplementary angle of 4 pi over 5, right? You know, if the first time you try to see it, it might not be that easy. But right now, I hope that you see that I'm trying to draw the symmetrical graph. Maybe just by eyeballing this angle, you should be able to see that it's just the same as that one, right? And this one is relatively easy to find, right? So just subtract 4 pi over 5 from pi. Of course, you know, since it's radians, then, you know, you probably don't see it right away. But if I were to say this angle is 120 degrees, you will see right away that this angle better be 60, right? Therefore, that angle must be 60. Now, at the end, you say, oh, isn't that just the reference angle of the 4 pi over 5? Yes, that's a happy coincidence. But something that you might want to also be aware of, right? Because there are not many you know, situations. You have the sine and sine inverse get together, right? You have cosine and cosine inverse get together, right? You have tangent inverse get together. That's all, right? And maybe think about sine, and it turns out that it's most likely the reference angle, right? At least that would be something you want to start with. But if I were you, I'm not going to count down the reference angles. I want to know why this is the correct angle and why it's pi over 5, right? How is that related to the 4 pi over 5? Okay. Now, that's the method we did in class, which is more traditional and standard, right? So I guess that people didn't like it too much. So that's why, you know, I'm thinking about what could be another way that you guys could like better. At least that the bottom line is you just get it right. So here's the second method. So it's going to have a formula. Maybe, you know, it would be better for you to just remember the formula and get it right. But I need to remind you first, what is the midpoint formula? If you're given 2 points, x1, x2 on the number line, how do you find the midpoint m? Well, you add them up, divide by 2, right? Right? You remember that? So now let's say if I provide you the midpoint, and one of the coordinates. Can you solve for another one? Say, I told you what m and x2 is. Can you solve for x1? Times 2 on both sides, subtract off the x2, right? All right, so now I box this formula because that's what you need. So the midpoint formula is not too bad, but the graph is kind of bad, right? Because I said, how many of you are confident enough to draw a sine curve, labeling all the special points? Then do that. You know, it's not that hard. Okay. So this is the sine, right? So let me label the angle that's parametric. 4 pi over 5. Where is it? So if it's less than pi, right? Well, you know what? If really that's bothering you, like how to locate this angle, you guys know pi is 3.14, right? Type it in the calculator, get a decimal, you know that's going to be less than 3.14. So it better be to the left of pi, and you realize that it's going to be greater than 1.57. That's why it's going to be in between pi over 2 and a pi. So I draw 4 pi over 5. What I want is I want another angle, which is going to be a point on the number line that has the same exact function value, right, as the sine 4 pi over 5. But what is the function value of 4 pi over 5? You go up there, find a curve, right? And that's how much the function value is, right? I don't really care how much the sine of 4 pi over 5 is. I draw a line to see that, can I find some other location? I'm going to be looking at the same exact value of sine 4 pi over 5, but I'll be looking at a different angle, right? So you see that the horizontal line is going to intersect a point here, right? And here, right? And here, or even many other places. But I make this dot a lot bigger because this is the one that tells me what theta prime is. But what makes this point so special? And you think that this is the angle we're looking for. Do you see that this point is on the restricted domain of the sine, right? And therefore, this is the only point you're going to look for. So the question is, how much will be this angle? And that's why you see that if you are able to plot the sine labeling on pi over 2, right? And you will see that theta prime and this angle theta will have a midpoint to be pi over 2. So now you just shuffle everything into this formula, right? M is what? Pi over 2, right? That's the midpoint. Double it, minus the other angle that you couldn't use, which is 4 pi over 5. Subtract it off, you get pi over 5. Right? Do you guys see it? So finding the alternative angle and the angle that you couldn't use, and it turns out that pi over 2 is the midpoint. As long as you can find out the midpoint, you're pretty much done. So basically, all I did to draw you those kind of graph and label everything is to try to find you the midpoint, which is pi over 2. Once you have it, because, I mean, seriously, you know, this is things that you couldn't use, put it in, right? So now, whichever method you like, right? But at least I have to pick one, or hopefully come up with your own, right? To show me in the test that, you know. When you say the reciprocal, you're talking about sine inverse? What do you mean by reciprocal?
It's you plotted 4 pi over 5.
Pi over 5, okay.
Yeah. The reciprocal, which is like pi over 5, right?
So, well, the way I get pi over 5 is I realized that this big angle is 4 pi over 5, and I wanted to find a supplementary angle. So I subtract it from the pi. Not always. because and I'll show you in the next problem that it's not going to always be like this, subtracting it from pi.
That number, but like not in the terminal, like the restriction value. It's just like, do I only do -5?
So, like I said, not always the case, right? So that's why, at least for this scenario, it works out. Now, guys, let's try a few more so you can see some subtlety, right? And especially what happens if you have the cosine and cosine inverse or tangent inverse, right? So let me first do 33. Right? Cosine inverse cosine 4 pi over 3. All right, let me put it down here. 33. Come on. Okay. All right, so 33, I want cosine inverse of cosine of 4 pi over 3, right? And I want to alert you that this is not 4 pi over 3. Why not? It's again too big, right? It's beyond the range of the cosine inverse, which only runs from 0 to pi, right? Therefore, I'm looking for another angle cosine theta prime, such that cosine theta prime is going to be equal to cosine 4 pi over 3, right? But I want to make sure that theta prime falls into the range of cosine inverse, which is 0 to pi. Okay. So now let's go ahead and plot the angle 4 pi over 3. Can anyone tell me which quadrant it is in? 4 pi over 3? It's in the third quadrant because it's greater than pi, right? Pi is the 180 degree, right? So it'll be somewhere over here, right? So this is a big angle, right? So that'll be 4 pi over 3, okay? So now you're going to have to remind yourself, how do we define cosine in a unit circle? Is it equal to x or y, or x over y, or x? Yes, so the x, right? That means if I'm picking a point on a terminal side, so I want another terminal side, right, for the angle theta prime, such that the point on that new terminal side is going to have the same x, right? So where I'm going to plot it, right? So if you don't mind, let me put the angle here. So this big angle is 4 pi over 3. So I want another terminal side, so that on the terminal side, the x is going to be the same as this guy. Can it be over here? No, right? It will be positive x. I want a negative x. So it cannot be in the right half of, the plane, right? And it's going to be over here. So that means now I'm going to reflect the graph of the x, right? By flipping up. Turns out, yes. But that's exactly why I'm saying that it's not always subtracting with a pi, right? The 360 is 2 pi, right? So you need to know there's some little catches. So now, how much is this angle, right? and now you guys see that, oh, isn't that just the same angle down below, right? And that's why Rebecca says, can you just subtract 4 pi over 3 from 2 pi, right? That's how you get it, right? Theta prime is nothing but 2 pi minus 4 pi over 3. And how much is it? Can you guys do that for me? 2 pi over 3, right? So now, the first question is, do we always subtract the angle from pi or 2 pi? Not always, right? You see that depends on whether you have the sine and cosine, right? So for the sine, you subtract it from pi. For the cosine, subtract from 2 pi. Now, the second question is the angle we just found, theta prime, the reference angle of 4 pi over 3? Could this be a reference angle? Or can a reference angle ever be that big? 2 pi? No, right? That's why if you're asking a Dr. Isn't that always the reference angle? No. That's why you see there's an exception, right? I mean, like I said, if I were you, I'd rather understand how I figure this out, right? So that's the first method, right? So let's try the second method. Or all right, so again, I want you to be able to quickly draw the cosine graph. All right, labeled in the 0, pi over 2, pi, 3 pi over 2, 2 pi, and just in case, you know, you have the negative pi over 2, right? Negative pi, that's good enough. So now, what's the angle that you couldn't use? 4 pi over 3, right? Where is 4 pi over 3? Okay, so it's greater than pi, but less than 3 pi over 2, right? So it'll be somewhere here. Let's call it angle theta, and that's 4 pi over 3, right? So if I want the cosine of this angle to be the same as cosine of another angle, I will go to the curve, right? And find out, maybe I can find another angle that has the same exact function value, right? But that new angle needs to be within the restricted domain of the cosine, right? Which runs from 0 to pi. So do you see that? Yeah, I should have drawn it better, but I hope you realize that this angle theta prime and a theta has the pi to be its midpoint. You guys see it? So now, what was the formula? 2m minus the other angle, right? So theta prime will be 2 times, what's the midpoint? Pi, right? Minus the other angle, 4 pi over 3. And you're going to get 2 pi over 3. There you go, right? So now, again, what's the point of drawing a graph? It will find you reliably what the midpoint is, because you need that, right? And this is the point, the angle you didn't like, subtract it off, right? Or if you just remember that, hey, for cosine, let's just subtract that from 2 pi. You remember. But hopefully you'll explain to me why you're subtracting from 2 pi. But I'll try not to be too nitpicking. You know, if you're able to at least explain how you did that in FRQ, you get the right answer, you know, I'll give you most of the points, or hopefully all the points. But the question is, how would you get the right answer first without going through the logic to make sure that you're in the safe place? Yes. Type it in the calculator and get the answer correctly first, right? Then go from there, right? Worst case scenario is you get a point without showing me any work, right? But hopefully you'll be able to, you know, do something about it. All right, so now let's see 32. Tangent inverse. 32. So tangent inverse of tangent of 4 pi over 5, right? 4 pi over 5. So I think that you're probably going to like the tangent inverse and the tangent a bit better. And also the graph of the tangent is a bit hard to draw. If you don't mind, let me take a shortcut just by taking a screenshot of the tangent graph. Okay, so let me, this is tangent. And again, this is not 4 pi over 5. Why is it not 4 pi over 5? It's obviously too big, right? It's beyond the range of the tangent inverse. So where is 4 pi over 5? On the number, okay, so it's less than pi, right? So it'll be somewhere here. So this is angle theta. Let's call it 4 pi over 5, right? So now I need to go down to the tangent curve. Oops. I see that. Oh, this better be the function value I want, right? And you see that it's going to intersect a whole lot of other places, right? Which point would you pick? The first one over here, the second one, or it will be the second one, right? And again, what makes the second point so special? Close to the origin, and it falls into the range of tangent inverse, right? Or the restricted domain of the tangent. So now, here's the tricky part. How much is that angle? I know that this angle is 4 pi over 5. And that angle should be to the left of the origin, so be negative. Negative pi over 5. Why is that negative pi over 5? Which is correct. How are these two angles related to each other? Or do you see a midpoint? It's kind of hard to tell, right? Because, you know, there's not a point labeled here. But do you see that you go into the left by exactly 1 period to get that point, right? You guys do remember that the period of tangent function, it's pi. That's the special thing about tangent, right? So if you add or subtract pi from any angle, the tangent is going to return the same answer. That's why you see that the third, actually not the third, the fourth point is you go to the right by adding pi to 4 pi over 5. If you go to the left, you're subtracting a pi. So now, guess what? For a tangent inverse, you have a much easier way without even drawing a graph. Because you can just play with that angle, adding, subtracting pi, until that angle falls into the range of the tangent inverse. Does it make sense? So, like say, forget about a graph. Let's see that, oh, you said 4 pi over 5 is too big, right? How would I make it smaller? Go ahead and subtract the pi, right? Because that's a period. And that's going to get you negative pi over 5, right? And that will work because that is indeed an angle in the range of the tangent inverse. Does it make sense? So, and again, well, you can always figure it out the right way, right? But if you're using the periodic property of the tangent to explain to me why you're getting negative pi over 5, you'll be fine. Okay?
But it's a tangent. Subtract pi.
Or adding the pi, you know, it depends on what angles, you know, what's wrong with the angle. Because if this angle is positive and too big, so you're subtracting a pi. What if it's a very negative angle? You're going to add a pi to make it, yeah. It will work out, but it will be unnecessarily complicated. And that's why, you know, I start with the second method right away. So let's do one more. I think that, you know, usually the third problem will be the magical trial, right? So let's pick a problem. Well, you know what? You guys pick one. All right. No. Wait. 30 what? 36 or 30? 30 or 37. Okay. Wait. I thought that tangent is better.
Oh, no.
All right. No. You know what? 37 is a good one, and you'll see in a second why, because it might be a trick question. All right, so tangent inverse. So tangent of tangent inverse of negative 9.8, right? All right, so now again, what was your first guess? Might say, well, negative 9.8, right? Is that right? That means, does that number falls into the range of the tangent? Yes. Right? What is the range of a tangent? Range of a tangent. The graph is right there. So that means this is correct. You say that, yeah? So that means your initial guess is correct. That's why 37 is a trick question, because you're so used to, oh, you know what? This is never going to work out. Let me add or subtract pi. You know what? That's why they designed the number to be a decimal. So they thought, oh, I'm going to add subtract a pi. So you forgot about, oh, that actually is going to be a good number you can use, because that does fall into the range of the tangent. And I'm glad Ryan pointed out, do you see the difference between the problem and the problem that we did before? The tangent is on the outside, not the tangent inverse. So that's the subtle difference, right? Well, let's take a look at 36. Yeah, Reese. Right, but can you explain why that tangent inverse on in the inside, it doesn't matter at all? Again, you can ask yourself the same question. Does that negative 9.8 falls into the domain of negative, tangent inverse? Yes, because the domain of tangent inverse is the restricted, is the range of tangent, which is all real numbers. So that means this number is fine. Right. Yeah. And let's see about 36. What is it? Cosine. Okay, that's the decimal. That's a good one. Okay. Cosine inverse of what is that? Thank you. 0.3. All right. So again, you're gonna guess. Could it be just 0.3? Right. Let's check. Right. You can do outside and inside. Does that 0.3 falls into the domain of cosine inverse? And the cosine inverse has a range of a -1 to 1, right? That's good. Now, just to do a sanity check, does 0.3 falls into the range of cosine? Of course, right? That means there you go, right? All right. All right, there you go. I have only. But that's the cheat sheet I gave you guys. So there are actually two different cheat sheets. The one I just gave Akeem and Rebecca is the inverse functions. You have it? Okay, cool. Yeah. And there's another one that has all 6 functions and their graphs that also tell you how the graphs look like, and also the range and domain. See that? This is the only thing that bothers you, right? Nothing hard. It's just that you have to somehow respect those trig functions, like spoil them, because you're not going to feed them something that they don't like, right? Because the calculator is going to spit out something that doesn't make sense or tell you there's an error, right? But if you work it out by hand, you never know that they actually complain. Right?
You saw the
I know. Yeah. I wish I can help with that. Yeah. I think there's some memorization curve you can look up on internet. It tells you that it's repeating that make it happen, right? So yeah, of course, there's, for example, like I told Rebecca, the reason why I didn't take biology as my major or chemistry is because it's just too many memorization, right? I can memorize a lot of things, right? You can tell, but I will still hate to memorize all the name of the bones, right? Or all the chemical compounds, whatever, right? The name of them, right? And the longest word come from medical field, right? It's great. Anyway, now moving on. For these problems, if you remember, when we did that, it was definitely better than those problems that has the function and its inverse, even though that it seems that it's mixing the function and another inverse, right? So let me demonstrate, for example, 39 for you. So maybe you're gonna see it a lot better than last time. All right, so 39 cosine tangent by half. All right, 39. I want to know cosine of tangent inverse of by half. Right? So I'm trying to figure out what this is. But honestly, I find something within the cosine very disturbing, right? It's inverse, right? So I hate to say inverse 10. So how about I just hide it? I call it, this is nothing but an angle theta. Once you do it, think about this. If theta is what I call tangent inverse of phi half. Can I quickly rewrite it as tangent theta is phi half? Right? That's better, right? You know, you're more used to SOHCAHTOA kind of things. So now let's go ahead and draw the right triangle to understand what do you mean by tangent theta is phi half. So I have an angle theta, right, in this right triangle. You guys label the sides for me. Tangent theta is phi half. So can you guys label the sides in this right triangle, given tangent theta is phi half? Opposite 5, right? Adjacent is 2. So now what is the hypotenuse? 29, thank you. Right, so you just add up the square of the 2 and the 5, right? Take the square root. So what do we want? We want cosine of this complicated thing, right? But I call it theta, right? Isn't that just asking you, hey, what is cosine theta in this right triangle? And it better be 2 over radical 29, right? If you rationalize it, it will be 2 radical 29 over 29, right? How do you guys like this problem? That was right. That was not bad at all. Right, please. Definitely there should be problems like that. It might not be a problem directly asking that, but things is, you know, potentially. I know what you're talking about. So maybe you have to put in a negative sign there, right? But all I can say is, have you ever seen a problem in the review packet or like that? So I don't want to say anything more. Right? Well, that's the fact. You guys all know it. Anyway, well, let me do 41. All right, secant tangent radical 3 over 3. Okay, 41 secant tangent inverse of radical 3 over 3, right? Is it tangent inverse? Am I right? Yeah, it's tangent inverse. Okay. Now, once again, let's hide this kind of a disturbing expression, tangent inverse, right, in theta. So we're going to call theta is tangent inverse radical 3 over 3, which means tangent theta is radical 3 over 3, right? And let's go ahead and draw the triangle with the angle theta here. The opposite is going to be radical 3. The adjacent is 3, right? And the hypotenuse is radical 12. Okay, so it will be, well, let's keep it radical 12, you know, if you don't want to simplify it, which is 2 radical 3, by the way, right? So now what we're looking for, we want secant of this guy, which is theta. So secant theta, you know, I'm not very familiar with the secant, but I know that it's the reciprocal cosine, right? So, okay, thank you. So h over a, so it'll be hypotenuse over adjacent, hypotenuse radical 2 radical 3, adjacent is 3, right? Oh, that's it, right? That's all you have to do. Let me write this in a better way. So it's radical 3 up there and a 3 here, okay? All right, the logic is always the same, right? Except for a potential negative sign, but I said that it's not very often. So this is complicated, right? Just overly complicated. So you hide this complication in angle theta, rewrite it in a form that you're gonna like better, and ask yourself, what does it mean? It means in a right triangle, you have those side ratios, right? Figure out the missing side and go from there. Because once you see the right, the right triangle, the SOHCAHTOA is gonna help you to find out all 3 functions. The reciprocal is gonna find you the remaining 3, right? That's all. Because I'm sure that right now everyone can remember SOHCAHTOA plus the reciprocals, right? There's no way you can miss that. All right. Now, any other question before I move on? No? All right. So now these are the seems the ultimate challenge, right? But they're not really that complicated. right. So now, if it's a MCQ, you guys know what to do. You hopefully not random guess, right? So educated guess with the assistance of a calculator. But you might say, Dr. Wang, how am I able to use calculator? Because my calculator doesn't take x's, right? So I have to plug in a number. Then listen to yourself, putting a number for x to see why it works out, right? So now, what kind of numbers would I put in for x for 43? Just to give it a try. 2, okay. Yeah, I'll do maybe 2 or 0, right? Things like that. So now, let's say, I think that 2 is better. Or you know what? I think that 1 is even better. Why is that? Anyone see that 1 is probably better? Because that's going to make these things very different from each other, right? And also, it will eliminate the a. Do you see that if you put in the 1, you get what? A 0 denominator, right? But if that works out for every x that is positive in a domain of the inverse 10, know that the inverse 10 has all real number for the domain, right? So it doesn't hurt if you take a 1, but somehow that a didn't work out. That means a is supposed to be wrong in the first place, right? But if you want to be safe, don't want to get yourself, the 0 denominator, putting x to be either 0 or 2, but I think that 2 is safer, right? So you don't get those kind of weird things to deal with. But I don't want to spend time asking you to do that with the calculator. So you decide. If you have time, use the calculator to plug in as many number for x as you can, screening through all the options and find out which one is correct. Does it make sense? Do that. But trust me that this one, I think that without a calculator, you're even faster. So let's try 43. Sine of tangent -1. 43. So I want to figure it out. Sine of tangent inverse of x, right? So remember that it's the same logic, right? I want to see tangent inverse. Let me just call it theta. Right? So therefore, theta is tangent inverse x. Equivalently, tangent theta is just x, right? Or x over 1, if you want. It looks like a ratio. So go ahead and draw the triangle. This is angle theta, right? Opposite is x. Adjacent's 1, right? And how much is the hypotenuse? You have to keep the x, right? Isn't that just x squared plus 1? Good. So now what we're looking for? Sine theta, right? What is sine theta? Opposite hypotenuse. X over radical x squared plus 1. Then please rationalize the denominator. Yes, you see that? You're better. If this is going to be FRQ, you better start working out by hand, right? And that will be x.
Please, this can be one of the 5. We'll say this.
Can this be all 5 actually like the same thing?
It's likely.
Oh.
I said likely. So.
But Dr. Wong, you're making this test, right? So listen to us.
Please.
Well, I'm the one making the test, but not the only one reviewing the test draft, right? Yeah, everyone has a speak. Wait, I'm fine with the test. Why am I bribing them for changing the test? You guys don't like the test. You bribe them. All right. Guys, let's focus. All right. So now, do you see that? This is way better than the things with the numbers. That's why it's funny, well, of course, the test won't say that, but I said, even if you don't see any numbers, I would say still try the calculator. Because the worst case scenario, if you don't remember how to do it, play with the numbers, right? And hopefully it'll be a MCQ that's all you have to do, right? So I'm not going to do any more because these are all the same, right? If you want to try them on your own, do that. All right, so let's see how much time I have. Now, these, now I seriously don't remember if I ever picked a question like that, but should you worry about these kind of questions if you were to have one? If you have one, you're so lucky right? So that's a free point for you. Use the calculator. But guys, realize that are those all angles in degrees or radians? Say in 25. Well, how do you know they're radians? Because to me, that 78, that looks like a degree. Good. If they say it's a degree, they have to put a circle there, right? A little circle. So they are radians. So I know that sometimes those problems are kind of evil. They put those degree numbers in it, right? Because your calculator might be sometimes in a degree mode or radian mode, because you might switch back and forth in a test, right? So alert yourself that, or you're looking for the radians of degree, and check if you have a way to tell if it's in degree or radians. Okay? So again, we're fine with that, right? It's just, calculator thing. Now, I don't think that I'll be able to do much about graphing, but I don't think that we really have to do a lot about graphing anymore. The reason is pretty simple. Have you guys all, well, I haven't input ways to D2 already so far. Now, do you guys remember, well, Tammy and Donovan reminds me some of the problems in Pearson is kind of hard to deal with, right? They have to drag the points, right, to make the graph works out. So you may or may not get a perfect score. If you didn't get a perfect score, it's not your fault, right? Because, when Tammy was here, well, I was trying very hard. I didn't get it for the first attempt, and I didn't feel embarrassing because, it's just not a good design. Anyway, so if you're able to even survive from those problems, of course, you might not feel that confident to deal with those problems in that test. But on my end, I see that you guys are really at the level, even above the level of the test we're supposed to be, right? But you might not trust me because, you haven't seen the test yet, right? But wait until you see the test, you will know that you're already at the level of the test, right? But I do want to spend some time with the graphing. I can probably do one problem. But then what you should do before come to me tomorrow is to, of course, try some of the problems that I didn't do, right? But I did cover the method and the skills, right? For example, those inverse functions and stuff. But when it comes to graphing, so you see that I picked from 21 to 24, right? That's the second packet, right? The updated version, right? So let me see if I have any more. So, okay, yeah, those two are pretty good. So 19 to 20, but you can also find my recording for February 2nd class. So that will be me talking about two problems, almost identical, but with different numbers. So what you definitely should try will be from 19 to 24, those 6 questions before you come to me tomorrow, right? One more thing. Does everyone have a cheat sheet like this? That's only one I have, if you want. So that's the 6 basic functions, right, and the graphs. So it tells you how the graph looks like, the dominant range. All right. So let me put it this way, right? So you might have to memorize a lot of identities for the first test. You might have to do so for the next 2 tests. But for this test, which you have to know or memorize, are not that many. But I'll say that these 6 graphs are definitely something you need to remember. Okay, and if you really have a hard time remembering it, hold on to the cheat sheet before the test, memorize it, within a couple minutes, right? And you know what to do once you get a test back, right? You know what? I don't feel like rushing to the graphing. So tomorrow we'll focus on the graphing plus any questions that you feel like bringing to the group, so that the rest of the class can benefit, right? And also you're welcome to stop by, but you know that Thursday morning will be potentially crazy, but if everyone's coming by for the last minute questions, right? Anyway, don't forget, start memorizing stuff.